This time, you should stop the video and complete Section A in your student workbook. Due to the extreme frequency differences between the UHF and the VHF channel allocations, two separate tuners are almost always required. In this portion of the video, we will concentrate on the VHF tuner stage. The VHF tuner is designed to receive television channels 2 to 13. Here you see a graphic representation of the VHF television frequency spectrum. You should notice a few things about this frequency spectrum. First, there are gaps between channels 4 and 5, 6 and 7, and a large gap between channel 13, which is the last VHF channel, and channel 14, which is the beginning of the UHF band. A portion of the gap between channels 6 and 7 is used for the broadcast of FM radio stations. As you may recall from your You Can Do FM radio videos, the FM radio bandwidth occupies all the frequencies between 88 MHz to 108 MHz. You should also notice that each television channel is 6 MHz wide. This 6 MHz bandwidth is the standard bandwidth for all television channels in both the UHF and the VHF channel frequencies. Channels 2 through 6 are designated as the low-frequency VHF channels. Channels 7 through 13 are designated as the high-frequency VHF channels. Each 6 MHz channel has a picture carrier located at 1.25 MHz above the low-frequency edge of the channel bandwidth. The color subcarrier is located at 3.58 MHz above the picture carrier, and the sound carrier is located at 4.5 MHz above the picture carrier. This places the sound carrier very close to the high-frequency edge of the channel bandwidth. This division of bandwidth is an industry standard for all television channels. Now let's examine the VHF tuner. Here you see a block diagram of a typical VHF tuner. The primary function of the VHF tuner is to select the desired channel, amplify the selected channel, and change the incoming radio frequency signal to a much lower intermediate frequency value. Now let's examine each of these sections and see what they do. The Ballon transformer is used as an impedance matching device between the antenna and the input of the RF amplifier stage. The Ballon transformer plays a key role in reducing the electrical noise caused by the antenna line. Here you see a Ballon transformer with a step-up ratio of 1 to 4. It is called a toroidal coil Ballon. The toroidal coil Ballon is nothing more than a coil wrapped around a donut-shaped core which is made of a ferromagnetic material. The primary advantage of the toroidal coil is that all magnetic flux is contained within the core material. The antenna filter circuit will consist of a series of resonant circuits that are used to prevent undesired signals from reaching the input of the RF amplifier section. This portion of the tuner could be considered as a pre-selector stage, which greatly reduces the interference from undesired frequencies. The tuned circuits in the antenna filter section will be set to resonate at the FM radio bandwidth and associated video IF frequencies. The RF amplifier portion of the VHF tuner performs 4 primary functions. It provides amplification for the weak RF signal, helps provide channel selectivity, improves the signal-to-noise ratio, and overrides any electrical noise which is generated from the oscillator mixer sections. As was mentioned earlier, each television channel has a bandwidth of 6 MHz. The video carrier is close to the low-frequency end of the channel bandwidth, and the sound carrier is very close to the upper end of the channel bandwidth. Therefore,